Welcome to the notes on line and rotational symmetry. So symmetry might be one of those words you've heard of before. Now we're going to talk about it specifically with geometry. And first we're going to start with line symmetry or reflectional symmetry. So what is it? It's when a line divides a shape into two identical parts. So again, I think when you guys hear symmetry, you kind of heard of the same on each side. That's exactly what it means. All right. So the reflection line, that is the line that creates the symmetry. So again, why do we call it reflectional symmetry? Because again, the object's the same on each side. So that's why they sometimes call line symmetry reflectional symmetry. So now that we know that, let's get right to it. All right, let's look at some examples. And all you're going to do is tell me how many line symmetry each shape has. Now this first one kind of has it already in there for us. You can see right here. If I put a line right down the middle, all right, it would be identical on each side. Or some people like think of if you folded it, would all the parts match up? Absolutely. So this one just has the one. How about the next shape? How many line symmetry do you think this one has? Well, as you look through it, maybe there's one here, but again, if you imagine folding, this wouldn't match up with this side. You can't really cut it in half because, sorry, that one. Again, if you cut it in half this way, all right, this wouldn't really match. These parts wouldn't match up. So this would be an example of no lines of symmetry. All right, looks like there might be one, but again, if you really isn't, because it won't be identical on each side. This one, again, you can kind of see, I'll go red here, but you can see one right down the middle here. So there is one. This one right here doesn't work because the wings would not match up. All right, so that one just has the one line. Next shape. Oops, sorry, I messed up. All right, next shape. How many line symmetry does this triangle have? If you look at it, sometimes there isn't. Again, there's no lines that I could draw that would cut this in half. So this would be a 0 lines of symmetry. And that's what we're doing for each example. This one, it already has it in there for you. You just have to count. Sometimes there's more than a couple, right? You got one, you got two. And then again, if you went diagonally this way, well, you could do that between each petal. All right, so this would be an example of 6. Okay, so there are 6 in that case. This one you can see, all right, we've got the 4. How many lines of symmetry does this one have? Again, it looks like there might be one but this angle would not match up with this obtuse angle. If I went vertically again, you can see that this angle and these angles would not match up. So this would be 0. This one, again, a lot going on. Looks like there might be, but if you look closely, I can't draw any lines of symmetry. Again, that's basically all these examples are. Can you find a line of symmetry? Here's one right here. Cut it in half, identical on each side. Now this one, I'll kind of put a star by it. I think most of you guys agree that we could put one here, okay? But technically, all right, you could say 0, all right, because it needs to be, technically, because it needs to be a closed figure or shape. All right, that one really isn't. So if you said 0, I wouldn't mark you wrong, but or if you said 1, if you drew it in there, that's okay as well. All right, a couple more. Again, you can see I can divide it right down the middle this way, be identical on each side. I can also do the same here. None of the diagonal ones would work, so that just has the 2. And the letter B, drew that off a little off, but if you put one there, you can fold it over each other, identical on each side. So that's line symmetry, guys. It's that simple. Rotational symmetry, a little bit different, okay? But again, that idea of being the same. So this time, rotational obviously goes with turn, all right? When you turn an image and the shape looks the same as the original. I kind of put a note there. If it takes 360 degrees, then there's no rotational symmetry. So again, now we can turn it and the shape looks like itself. Now the angle of rotation, this is the one thing that you guys need to know. It's the degrees you turn the object to make it look the same as the original. How do we find it? Here's the one thing you guys need to know. All right, you would take 360 degrees and you would divide it by the number of times, all right, you can turn it and it looks the same. Again, that's not real mathematical, but you guys get the idea. So the number of times you can turn it where it looks the same. Now, quick little note, all right, back to the original, the 360 degree turn, all right, counts as 1. So don't forget that last turn. Okay, so that's how we're going to find the angle of rotation. That's all. The line symmetry, you had to find the number of lines, angle rotation, the angle that your degree of your angle of rotation. That's all you need to find. So this first shape, this S, how many times can we turn it? Well, I'm going to go clockwise. If I turn it this way, I can do it once and then back to the original. So I think I can do it twice. So this one would be 360 divided by 2, so the angle of rotation then would be 180 degrees. If you can turn something twice, the angle of rotation is a 180. This figure, kind of the recycling. All right, again, I'm going to turn everything clockwise. I can rotate it. I can kind of rotate it once. It'll be back to the original, twice, 3 times. If I turn that thing, all right, so I do 360 divided by 3, that would be 120 degrees. So if you turn something 3 times, it's 120 degrees. This orange slice. Okay, so again, I think I can turn it many times and it'll be the exact same. So I'm going to count it up. All right, so 1, 2, 3, 4, 5, 6, 7, and don't forget the original 8. I can do it 8 times. So 360 divided by 8, that's going to be 45 degrees. Okay, a couple more. I mean, that's all we're doing for this one. This one, again, I could rotate it once and then back to the original. So this would be 360 divided by 2. That'd be another 180 degree turn. This one you can see again, 1, 2, 3. So 360 divided by 3, 120. All right, this figure, we haven't done one of these. We can definitely do 1, 2, 3, 4. 360 divided by 4. Well, that's going to be 90 degrees. The star, 1, 2, 3, 4, 5. 360 divided by 5, 72 degrees. And the last one, an arrow. All right, if I turn it this way, all right, you guys will notice, and I can try that here. I can see if I can play around with this thing. If I take this shape, oh, can't quite, but if you guys can see, if I try to turn that, all right, I cannot do it at 180. It won't be the exact shape. So this would be 360 degrees. So this is no rotational symmetry. If you can only turn it 360, that's not really rotational symmetry. Symmetry. All right, ran out of room there. All right, so again, if it takes 360 degrees, no rotational symmetry. So now that you know what symmetry is, we now know what line and rotational symmetry is in geometry.